Thank you. Hello, everyone. It's so nice to see so many diverse faces here to listen about this topic, of which I'm so passionate about. My name is Fiona. I'm a developer and also a consultant with ThoughtWorks. And today I would like to share with you some of the things that I've learned and researched and discovered about the social implications of bias in machine learning. But before we get started, I think there's a lot of terms there, and some of them might need defining. So to start with bias, what do I mean by this? Well, we can take examples from just the real world. So we have, I won, therefore gambling must have been a good idea. This is an example of outcome bias, which could potentially lead to poverty. We've got, there's a large man walking alone at night. Maybe he's dangerous. This is stereotyping, which could cause fractioning in society. We have, people often say that mobile phones cause cancer, so that must be true. This is the bandwagon effect, and it also leads to misinformation. So we have an idea of what bias is. What I've talked about is social bias, and I want to call out a distinction where I'm talking about social bias, but not statistical bias. The reason I think it's important to bring this up is because in machine learning, we often hear about statistical bias, and that is a really important topic that deserves its own talk. But specifically now, I want to just clarify that that isn't what I'm going to be talking about, which is nice, because it means we get to chat about the human condition rather than sit and listen about maths. So what do I mean by social bias? Well, by that, I just mean prejudice, whether that's a conscious or an unconscious prejudice, against a group based on some kind of protected term that they might hold, so maybe race or gender or sexuality. Statistical bias, that thing that I'm not talking about, just to get a definition as well, is when we're trying to take lots of different measures and average them out, and we compare that to the thing we were actually trying to measure. So that's where we get statistical bias. I'm not going to talk about that. Another thing worth mentioning is that bias is not inherently wrong. We don't need to completely get rid of it, or we wouldn't be able to function in the world. We kind of need to be able to make some assumptions about things because we have so much information, and we need to actually live and make choices. So bias is okay, as long as we're aware of the fact that it is a shortcut, and we could be reinforcing things we don't want to reinforce in ourselves and in the world. The other thing I mention is machine learning. Can I get a raise of hands? Who here works in machine learning currently? Cool, we've got some people. Who already feels comfortable, they fully understand what machine learning is? Great, okay. So sorry to the people who raised your hand just now. I just want 2 minutes for anyone who didn't feel as comfortable so we can all be on the same page to begin with. So by machine learning, what I'm talking about is I'm going to say algorithms and models. I'm going to use these terms interchangeably in this talk. This is the definition I'm using. So I'm talking about some kind of software that performs a specific task. So not generalized AI, but also not just a bunch of if-else statements kind of wrapped up and called ML. I mean something that actually uses patterns to make inferences. So that's the definition for the context of this talk that I'm going to use. To dig a little deeper into what that really means, these are some of the ingredients that we might have if we had some kind of machine learning product. So we'd start with what is the question that we want answered. Then we would have some kind of data, ideally relating to that question. A model would then get generated based on this data to answer that question, and we would test it with a subset of the data which wasn't used to train the model. To give an example of each of these, let's say we had a question of which candidates should we be hiring? And we had some data relating to resumes and the performance, the outcomes of different hiring decisions from the past. We could then make some kind of inferences based on those outcomes and try to generate a model that would help us to decide which candidates to interview. And then that would be great. Hopefully it would work. We could test that using some data that we held aside and see whether or not it accurately determines who will be hired. Another example would be these two pictures of cats, which I took. And to find them for this talk, I opened my Google Images library, the Google Photos one, which has all your personal photos, and I was just scrolling through it, looking for pictures of cats. But to do this, I was using all of the things that I remember from my learned experiences about what cats are. What is a cat? It's usually inside, it's quite fluffy, has a tail, and I was trying to manually work out which pictures were of cats. But that got tedious pretty quickly, and so I just typed cats into the search bar, and bam, these two images. But how did Google Images' algorithms work out these are cats as opposed to all the other photos I have? Well, I can't know because I can't see their source code, but I can assume it's something like this. They would have had a bunch of pictures of cats that were labeled cat, and a bunch of pictures of not cats that they labeled not cat, and then fed all of those into a model to generate something that, when tested, could successfully say yes or no, this is a cat. But the people who built this, the awesome people who relied on some of the benefits of machine learning to create this cool tool, they wouldn't be able to tell us, oh, the second pixel on the bottom row from the right, how much does that pixel impact whether or not this is going to be labeled cat or not? Because it's so complex. And that's really part of the benefit of machine learning, and the risk, is that it is often a black box. We were able to use algorithms that we ourselves couldn't have thought of or might not even understand, and that's a huge benefit. But it also comes, like every benefit, with a drawback. If we lose out on observability in lieu of getting accuracy, then we might not know exactly why our model did what it did. And if we don't know why, then we don't know whether it was accurate. So it's about making that trade-off, and I'll talk more about this in a minute. So how's this going to go down? Well, I have broken down the process of capturing data, generating a model, and then in the end actually using that model into the 6 different sections, which I'm going to talk about in turn chronologically. And I want to, for each of them, highlight some of the risks that exist, some examples of where those have actually happened, and then what are some mitigations? What can we actually do as technologists to help make this a better thing than it currently is? So, now that our definitions are done, we can start looking at data collection. With data collection, this is the thing that's going to really determine the model. So it's super important that it be something that really answers your question, but also something that really represents your future state. A lot of the time, we have existing data within our organizations, and it seems obvious to just use what we have. But that isn't always the best, because that data wasn't necessarily collected with that question in mind. And the way in which someone goes about the process of collecting data really has an impact on what data they select. For instance, if I asked you about your earnings as the tax office, or as someone you were on a second date with, or as your friend who was in financial hardship, you might answer that question a little bit differently. One example from Boston, they had this issue in Boston where there were a lot of potholes throughout the city. But they didn't know where the potholes were and which ones were more impactful to the people. So what they did, like any modern place, they made an app, and you could put this app on the passenger seat of your car while you were driving around, and it would use the accelerometer and the GPS and determine, did you go over a pothole? And how much did that impact you? And that was great. They were finding so many potholes. It was brilliant. But they noticed one thing, that most of the potholes they found were in really wealthy areas. And that seemed a bit interesting to them. So when they dug a little deeper, they decided to put that same app in public transport and the garbage trucks, and that's when they found all these extra potholes which they'd never seen, because only really wealthy people with modern phones and a spare seat in their private vehicle were capturing the data previously. This is a great example of data not really speaking for itself, but actually echoing those who collected it. People say, like, the data speaks for itself. It honestly doesn't. So being aware of the bias that exists in the collection process is really the only way to then be able to do anything to mitigate it. Another great quote Raw data is both an oxymoron and a bad idea. We should cook our data with care. I think this is also really poignant. The idea that machines are somehow this completely unbiased and only logical creation ignores the fact that humans are involved in making machines and in training models. So we as the chefs need to be careful about the way in which we cook our data. A common saying in machine learning is if you have rubbish in, you'll get rubbish out, or garbage in, garbage out. I think you could say the same for bias. If there is bias in your data, there will be bias in your output, and so it's pretty much inevitable. One great mitigation for this is Open Data Institute have something that they call their data ethics canvas. This canvas looks much like this, but with a lot more text. It asks a lot of questions. It's not meant as a checklist for compliance. It's only meant to help facilitate a discussion. So in a team, people can look at these questions and try and answer them about their product. And they can learn things like how this product might negatively impact people. For instance, could it cause harm? Could it be used to target people, to unfairly restrict access? Or could it be seen to do any of these things? Sometimes perceptions are reality. And could we minimize these negative impacts? For instance, what steps could we do to measure whether there is any negative impact from our product? And that's the only way we could then mitigate them. So all data does have bias, and we need to collect it carefully. We should be really skeptical of that data we already have, because we don't really understand the motives around when it was collected. And we can use some tools, like the Open Data Institute's Data Ethics Canvas, but also Ethical OS, which is a similar set of questions, in order to just try and, within the team, think about what are the impacts of what we're doing. But what about once we've collected all of that data? Is more really more? Is there some data that we could throw away that would actually make what the outcome are from our model more accurate or better? For one example, I want to talk about audition-only orchestras. No, this doesn't sound very relevant. Audition-only orchestras were traditionally almost exclusively men. And this was logical, it made sense, because most of the people who knew how to play instruments were men. They were the ones who had this education. However, as that changed and more women entered education where they could learn about how to play instruments, for some reason we didn't get more diversity in our orchestras. So what someone decided to do was, during the audition process, to just close a curtain so that no one could see those people who were making the music. And they expected that this would have a great result, to reduce the data and create a more accurate outcome. However, it didn't. It seemed to be the same. And people wondered why. Until they learned that when a woman walks onto the stage, she might make a clippity-clappity sound with her heels. And this was enough to put in the back of the minds of the people making the decision the information that she was a woman. And so when they asked all of the people auditioning to remove their shoes, suddenly women could play instruments. There was diversity restored to the orchestra. Can we do the same with the data that we've collected? How can we increase accuracy by decreasing the amount of data we have? Does anyone know what all of these terms have in common? These would be known as the protected attributes. And there's a really great set of laws in the country where I was born in Australia, which protect these attributes from any decisions about hiring, promotions, firing. You can't use legally any of these attributes to make those decisions. Researching, there are some similar laws in the EU that don't cover quite as many of them, it seems, and they have differences, but still there are legal ramifications to using these kinds of attributes in hiring decisions. Another thing that there could be is data that isn't directly any of these, but is really a proxy to that information, and therefore is equivalent, really, to having this information. Sorry. But what's great is that if we're using machine learning rather than maybe a recruiter who can't easily forget and put up a curtain and ask everyone to take off their shoes. If instead we've got machine learning, we can directly delete all of the lines that were about those attributes and all of the ones that were proxies to those attributes. And that's a really powerful tool because we can decide what it is that the machine sees. We can decide what that data is that we feed in. So as painful as it can be to delete something when you have this impressive amount of data and it sounds cool and maybe it's not actually helping, or maybe it's not actually legal to use the information that's there. So being aware of these legal ramifications is important. Reducing the data can sometimes increase the accuracy or the fit for purpose of the model. And even though forgetting is difficult for us, it's much easier for machines. So let's leverage that. So the last part on my three-part trilogy about data is to add missing data. But what is missing data? If it wasn't there when we measured it, clearly it doesn't exist. Or maybe it doesn't exist yet. When we're raising models, when we're training them for the world, we are only doing this based on what happened in the past or what is happening right now. But a lot of the time, what we want that model to be able to do is tell us about the current or the future situation. So we can't only enable them with what we've seen in the past and expect accuracy in what they can tell us about the future. Just like when we raise children. I don't know about you, but during the time I was raised, it was very common to say something like, "Oh, let's go to the doctor and see what he thinks," as if this was a normal sentence. But now I think a lot of parents would say, "Let's go to the doctor and see what they think," if they don't know who the specific doctor will be, because they don't want to imply to their daughter that she couldn't one day be the doctor. In the same way, we can train our machines for what we want or believe the future world will be, rather than what the past data says about historical. One example for this is Google Translate. I don't know who here was in Yu's talk just before lunch about a similar topic, some people. He touched on this as well. We have this great tool, Google Translate, that can help us to know what one word means in another language. But sometimes the situation of the countries where that language is spoken is what we really get and not the general translation. For example, here I've picked Malay because this language has a nice equivalent of she or he, but it's actually gender neutral. It's a they equivalent. And I've got here some different things that I've written in Malay. And I guess because of the fact that I'm talking about this in the context of this talk, you can guess what some of these might be. But as we can see here, Google Translate has said, he is a doctor, he is a soldier, she is a nurse, etc. And I can understand why. I can see why this has happened, because if Google's got all of this vast amount of information about the world and all of the data about all of the language that has been used in the past, it's going to see more instances of he being a doctor and she being a nurse. I mean, that makes sense that that would happen. But I guess that only becomes a problem when that's not the pattern we want to reinforce, or when that's not the pattern that we expect in the future. Something nice that Google has done more recently to resolve this is they show now two alternate translation options. This is not yet, it still assumes a gender binary, but they have some plans to work towards that as well. And so this is just a great example of how a team of developers was able to implement a feature that helped to not put the image in people's minds that only men can be doctors. Because really the data does show us that the trajectory is towards equality. So if we want our data to be accurate for the future, where we're making our predictions, we do need to look at this kind of information as well. Some ideas I had about how this could be done differently would be, what if we fed in all of the data we have, and then all of the data we have again, but with flipped pronouns? Or what if we weighted more recent information more highly, so that we capture trends like this? There's a few different ways in which we could approach this. I'd like to introduce you also to Joy. So Joy is a researcher with MIT Media Lab, and she did her master's thesis about how different facial recognition software is more or less accurate when attempting to recognize someone of a different gender or a different race. What she found was that a lot of these different frameworks that she was analyzing were much, much worse at being able to recognize women of color than any other group. The reason why she decided to do some research into this is because she had been working on an art project that involved the use of facial recognition software. And I'd like to share with you her experiences with that.
The stim I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask.
I think this is a really powerful example of a time when a model is not fit for purpose. So given that its goal was to detect faces, and it was not able to detect a face, it's really not meeting the acceptance criteria. Something that Joy in her activism work really promotes is the idea of diverse teams. We didn't really need more reasons to have diverse teams. We already have research that shows us that they lead to better decision-making and higher financial results. But this is just yet another example of how when we have a team that reflects the people who will be impacted by the product, we end up with better products. Where that might not be possible, a pretty cool tool that anyone can use is the Tarot Cards of Tech. These appeared on the ThoughtWorks Technology Radar in the most recent edition. And they're a set of different questions, again, that teams can ask themselves about their data or about their product. One I want to call out here is the forgotten, which encourages the reader to think about all of those people who they might not have considered as users or people who were impacted by their system. And one question I like to try and ask is, what would make somebody give your product a 1-star review? If we can think of all the different people in the world and what might make each of them give a 1-star review, we might be able to avoid those reviews before they happen. Combined with that, Google have Facets and Facets Dive, which is a cool tool for visualizing who is actually represented in a data set, so we can get an idea. This is census data, just used in their example, and we can see here that it mostly represents married professional white men. And that's fine, if the predictions that we're making are about that group. If they aren't, then maybe we've got some people in that forgotten category, and we simply need to collect more data. So sometimes things aren't fit for purpose unless we add the data that's missing. Diverse teams are one approach that can help with this. And Google's Pair initiative do have a couple of other tools as well that can be useful. The next thing I want to discuss is about observability and justification. So this is more about that black box, that trade-off we were talking about before between having really complex and accurate fancy models and something simpler, maybe less accurate, but easier for us to digest and understand. Recently with the GDPR, there was a pretty cool bit of legislation introduced, which was about the right to an explanation, it's been coined. What this talked about was it said that data subjects had the right to know about the existence of automated decision-making when it impacted them. But they didn't just have the right to know that it existed, they also had the right to get meaningful information about the logic involved. So really it's saying we need to open that black box. And also they needed to have an idea of what the consequences would be, the potential consequences of that decision, which I think is brilliant because it raises that question with the teams as well. What are the potential consequences? So if this means that we need to open the black box, how do we go about doing that? We don't want to reduce accuracy down to something that we can understand and explain to our users. We want to be able to leverage the really cool different algorithms that we have at our disposal and get amazing results. So we need something. We also want something just because we like to understand why. If we fix a bug and we don't know what fixed it, we're a bit skeptical that we've actually fixed it. In that same way, If we get the result we expected, but we don't know why we got that result, we can't necessarily trust it was for the right reasons. So that's where Lime comes in. Lime was a research paper and also a Python library. So if you're into pip installing things, that might be something to pip install tonight. And what it does is it helps give visibility, some level of observability. What's really exciting about Lime is it's model agnostic. So it's the local interpretable model agnostic explanations. That's a mouthful. Let me start again from the bottom. So explanations. It provides some kind of understanding, some kind of reason for an outcome. Model agnostic. It doesn't matter if it's a random forest, if it's a neural network, if it's SVM, whatever. This will work as an approach. It's also interpretable, so people can see the result and understand what that means. And it's local, as in local to the area where that decision was made. Probably we need an example. So this is a picture of a tree frog, or at least the p-value is 0.54 that it's a tree frog. But why? Why was this given that p-value as being a tree frog? Well, what Lime does is it generates a whole bunch of alternative images, just with the pixels toggled off. And when we have hundreds and thousands of other tree frog images, but with not all of the information, we can get a much better idea of exactly what combination of pixels led to that decision. So we can see here in this top one, with only that data, it was pretty confident it was a tree frog. What that then gives us is kind of these lines for where we can draw a line and find out where exactly, what part of this image was what gave it that result. And that's when we get that example of the justification. But if that's a bit too much Python, there's also the what if tool from Google that can help a bit with these kinds of issues, but doesn't require any programming. It helps to see how different cutoffs in models might help with getting more accuracy for underrepresented groups. What I think is really cool about this is when we see people make decisions, or even when we ourselves make a decision, it's really hard to tell what a post hoc justification is when compared to the actual reason why we drew that conclusion. And this is a flaw, really, in the human brain. But if we use machines for automated decision-making, and we get this level of observability, then maybe we have something more powerful for this decision-making than even the hardware that we currently run in our heads. So in order to trust what we've built, we need to understand why it works the way it works. Lime can help us with opening this black box, regardless of the algorithms and how we're implementing them. And also, both Google and IBM have some products for this as well. I think it would be impossible to go on without also mentioning feedback loops. We were talking before about how we try and raise children for the future world that we expect or that we want. Part of that is because we are really creating the data that the future decisions are going to be built based on. Whatever it is that our predictions spit out is having some impact on the world, and then that impact is what we're going to measure to form the future data. Facebook recently got into a bit of a media situation because of the way that they were showing advertisements. It was much more likely that you would see an advertisement for a high-paid job or some kind of housing if you were maybe white or maybe a man, but you were much more likely to see, say, secretarial work if you were a woman. And this wasn't because people were specifying that when they asked who they want their ad to be shown to, but instead this was being reflected in the data about who ended up seeing the ads. And that's Facebook's algorithm working that out. The damage this could have is that if we only show ads to a certain group, then we might only really have those people aware of that job opening or that opportunity. When we have data that leads to a model, that leads to a decision, that's one thing. But when that decision leads to an outcome, and that outcome leads to future data, that's when we get a cycle. And when we've got this kind of feedback loop, really we're only automating the problem. If we haven't reduced the bias to begin with, we're just making it that that bias can exist even without us. And that's even more dangerous. So if you don't fix the bias, you're just automating the bias. A great example of this is when we try to use machine learning in decision-making about things like predictive policing or about jail sentences. In these cases, if we look more, we're going to find more problems. And if we put someone into a higher security prison for a longer period of time, we're more likely to have a negative impact on their future life. There was an organization who looked into some of the tools being used currently in the US, specifically the tool Compass, and they found the following. So here we're going to look at the false positives and the false negatives of two different groups. So the first is the false negative of someone who was labeled of high risk to reoffend, but actually didn't reoffend. The second group is people who were labeled to be low risk, unlikely to reoffend, but actually reoffended. So these are the two things that when training a model, we will be optimizing not to have too much of, because these are the error states. And what was found that was, for people who were white, it was more likely to accidentally think that they weren't going to reoffend when actually they were going to reoffend. I know it doesn't equal 100 because this is only the negative cases. But for African Americans, it was much likely to think the opposite and to accidentally believe that somebody was going to reoffend when they actually weren't. And it's not so accidental because really this is not dissimilar to how humans make mistakes. And because we've trained this on historical data, we're probably going to end up automating the same problem which we had before. And that's what happened. As always, I think the meme says it all. Do you want to reinforce stereotypes and discrimination because that's how? But can I try and find a positive? I will try. We already know that our existing systems, which rely on humans making decisions, are also biased. So is it possible that if we can fix the bias and automate it, that we could lead faster and in a way that might be more permanent towards a solution that doesn't have so much bias? I hope so. So today's outputs are going to be tomorrow's data and tomorrow's inputs, and we should be careful of what those patterns are that we're going to be reinforcing. Lastly, I'd like to discuss the usage of these models once they go out in the world and they're used by people, and also the governance of that. I think we can learn from other industries that have come before. Pharmaceuticals is one example. They've already made a lot of mistakes, gotten a lot of bad press, learned a lot of lessons, and applied their own mitigations. They have things like, if I buy a product, I will be shown what are the capabilities of that product. What are its limitations? I'll know what the active ingredient is, the thing that makes it work. I'll know when and how I can use it, and maybe when it shouldn't be used. And there'll be some safety measures, like this cool cap to stop my children from ODing, because then I'm trusting that the people making the product realize it can be harmful and are trying to protect me from it. Then we've also got product recalls. If I purchase a product and it doesn't work, I might even get a refund, but I'll definitely be told and it will be taken off the market. Can we not apply all of these to technology products in general, but specifically machine learning? Because really, it is only built by humans, and it's as fallible as we are as humanity. But the problem comes when our users think it's magic, when we've told them it's intelligent, when it's really maybe not. One example, about a year ago, there was some great clickbait. Amazon's facial recognition technology managed to match 28 members of the US Congress to mugshots of criminals. And so this was all over the internet. People were pretty entertained. But what Amazon said in response was that this was an invalid test. They said it was invalid because they'd only used the 80% confidence threshold, which was the default in their product when making this test. But if 80% is not good enough, why is that the default? I would hope and I can't see, but I would hope that when Amazon provide these products to law enforcement as they do, that they would change that default to something more in line with what they themselves said would be appropriate for that situation. But what's been happening instead is that regulation has stepped in. So Microsoft is asking, can we please be regulated? When an industry asks to be regulated, you know there's a problem. And different jurisdictions have decided to stop using this technology for law enforcement because they don't feel like it's ready. But whose responsibility is it really? Is it us as consumers or as technologists? Is it the government to regulate? Is it the companies themselves? I ask that question. OpenAI developed some really cool technology a couple of months ago. They were able to create really believable, human-readable, as if it had been written by a person, text. And they thought, this is amazing, we should show this to the public. But then they realized, could this be dangerous? They thought about it in conjunction with the other recent deep faces technology, which could make human believable faces, and they thought, actually, this might be damaging. So even though OpenAI usually open the AI that they create, in this case, they didn't. They showed only a very cut-down version to the public, and instead they listed the risks that they'd seen, and they talked about how they wanted to open a discussion. And I think this is a great example of what we can do, sometimes not release the cool, shiny thing that we spent lots of money on because we see that it might be a problem. And I guess on the other side of that, the product recall. When we discover that something has a bug, when we discover it's not good, we can actually take it back. It's much easier for us in this industry than it was in the past to quickly patch something, to fix it, to remove it at all. And this is an incredible power that we all have. In society and with humans, I have to actually incubate a human and push them out into the world. But with technology, I can just git push, and if I've got good continuous integration, I can put that into the world. So this is really a huge power that we can use for good if we're careful. So can we inform our users? Can we warn them? Sometimes even restrict them to try and make sure that our products are not damaging? What are ways that we can all demand better products, better governance? And unlike humans, machines can be updated so much quicker. We can use this to our advantage. To quickly summarize that, all data is going to inherently have some bias. The collector and the intent behind that collection is going to show through. So we need to remember this. We want not only to fix the potholes in rich suburbs, we need to be careful of the existing data we have. We need to think about how what we feed to our models is all that they know. And so we can do that with a lot of intention. And this will cause us to have those beautifully diverse orchestras that we love. We can encourage diversity in teams, and when we don't have it, we can try and still think of those people who are missing from the room and how they could be impacted by our products. We can use tools like Lime to help us to open up that black box and get some real insights into how the tools that we build work and why they do what they do. We can be aware of the fact that whatever we create in the world might look like code to us, but it's a real product later on, and that's going to impact the future of the data that we see. We can be aware that if we still have bias, we're simply automating it. And we can learn from other industries that have come before us and see how they've mitigated the same kinds of issues. So I leave you with this. If not me, who? And if not now, when? We are all people who have the information and the power to do something about this, and I encourage us to. Thank you.